So, welcome back to this class in related to quantitative finance. So, as we were discussing that considering that short selling is there or not there, you have to take a decision whether to include that particular asset in your portfolio, yes or no, depending on different criteria. Now, if you remember, the criteria was that if the return of a particular stock is greater than or equal to RF, which is the risk free interest rate, you will include that. If it is not, obviously you won't include that if short selling is not there. But if short selling is there, then for those stocks where the return is not in excess with RF, which is the risk free interest rate, obviously it means you will short sell those assets and try to utilize the money in trying to buy other assets. So, there is a certain C star cutoff which we have already discussed. So, in case, say for example, for each and every stock you will find out the CI value which is given by this formula which you already explained. So, if this is equal to greater than or equal to C star, so obviously it will mean that you will include that stock. If it is less than or equal to C star, you will obviously not include the stock if short selling is not allowed. And obviously the vice versa would hold true, where in this case, the last case where Ci is less than or equal to C star, you will consider them to be included, but in the short selling mode. Now, the calculations I have if you refer to the last class, the calculations are very simple. What you have is basically the value of sigma square m, which is the market risk, corresponding to whether you are trying to calculate it for the Bombay Stock Exchange or New York Stock Exchange or NSE, whatever. And this value Ri minus Rf is basically the excess return which you have over the risk free interest rate. This beta j is the corresponding risk which you have from the beta value for that particular stock, and the sigma square epsilon, suffix epsilon, is the white noise. So, that means if you remember, which we had discussed, there was one set of risk which was non-diversifiable and another set of risk which was diversifiable, basically systematic risk and non-systematic risk. So, if you plot the values of write down for the values of CI, so if you include only one stock, the CI value is 1.67. If you include the second one, it is 3.69, so on and so forth. So, there is a tipping value C star, after which as you keep including more stocks, the value starts decreasing. So, this is basically the C star value depending on the case. So, for those particular stock which you will include if it is greater than C star, and for those stocks you would not include if there is no short selling if the value is less than C star. Only one thing I will try to recollect and also make a point to the students, that when you find out C star, all the summation would be done, or the Ci value which you find out, all the summation would be done for the values of j is equal to 1 to I. So, if I is 2, excuse me, you will sum up all the values starting from 1 to 2. If I is 5, you will sum up all the values for 1, 2, 3, 4, 5, considering they have 5 different assets in your portfolio. So, this C star which you have said is 5.45 is the maximum value, implies that for all such assets above you include them in your portfolio, for values lower you do not include if short selling is not there. Remember one important thing, as I mentioned, that summation is being done from j is equal to 1 to I depending on how many i's are there. Now, once you find out the value of C star and those values of stocks which will be included, obviously you have to find out the value of weights, because weights is important. The reason being, once you find out the weights, you have to find out their overall returns. That means Wi is the weight of that particular stock, Ri is the return, and similarly you have to find out the variance. So, where the first term is the weight for the ith one, second term is the weight for the jth one, third one is the covariance between I and j, which has 3 terms. One is the correlation coefficient between I and j, the second one is the standard deviation of I, and third one is the standard deviation for the jth one. So, by formula, without again any proof, we can find out that the value of Wi is given by this, while C star value is that n. Now, this n which I am writing is not the whole set, is that value of n which will basically make that particular portfolio so called optimum, considering that all the values of Ci's are greater than or equal to C star value. So, for the problem when there is no short selling, we find out C1, C2, C3, C4, so on and so forth, and then once you find out the weights are given here. Remember, they are non-normalized weights. If you add them, they would never add up to 1. So, once we find out the normalized weights using any normalization techniques which we have already discussed, a simple one where which would be Wi divided by the sum of Wi's. So, once you have that, these Wi's would be the non-normalized one. Once you find them, you basically have the normalized weight. So, if you add up them, they should basically add up to 1, which means the whole amount of money which you have to invest is being invested in the first, second, third, fourth, fifth stock in proportions of 28.4, 27.6, 22.0, 19.5 and 2.3 percentages respectively. Now, the problem has the condition that short selling is being allowed. In the second case we are considering, riskless lending borrowing is being allowed. That means you can borrow from the bank, utilize that money to buy different type of assets. And obviously, if there are different type of stocks where the returns are less than RF, obviously you include them in a short selling mode. That means try to borrow them and sell them and utilize that money to buy different stocks for which the returns are more than the risk free interest rate which you are planning to invest. The rule works as follows: find the excess return to beta ratio for each and every stock, as we did for the last set of problem, under consideration and rank them from the highest to the lowest. The optimum consists of investing in all the stocks where the values are greater than equal to C star, and also investing in stocks in a short selling mode for which the value of Ri minus Rf by beta is less than equal to C star. So, again let us consider the problem. There are 10 stocks, Ri's are given, Ri minus Rf is also given in the third column, and the beta values are given. Sigma square epsilon is the white noise, and finally you have basically ranked them according to Ri minus Rf divided by beta, which is basically the excess return over the risk free interest rate divided by beta. So, once you have that, then again we follow the same procedure. Find out the ratios of the excess return divided by the white noise multiplied by beta I for each and every stock. Find out the ratios of beta 1 I square divided by white noise, which is the variance, and then again start summing it up. So, but now remember one very interesting thing: if you see all the values are equal. Now, you may be thinking why? The reason is very simple, because if it is short selling, whether the stock has excess return or less than excess return, you are going to include that in the portfolio. So, if it is excess return is positive, they will be doing in a positive sense. If excess return is negative, you will be doing in a short selling sense, but not for the other problem. In the last problem we saw that you would basically go step by step and include those stocks only where it was positive returns. For negative returns, where Ri minus Rf divided by beta, those values, and considering the values of Ci's which you have found out, if Ci was less than C star, then you would definitely not include. So, your summation was being done from j is equal to 1 to n, where n is that number of stock which you are trying to include, not the whole set. But here now you will include the whole set, because all of the stocks have to be included either in the positive or the negative sense. So, once you find out the values of excess returns multiplied by beta divided by the variance of the white noise, so the values come out to be constant, because n is fixed here, which is about 44.1 divided by 10, and the values of beta square j divided by the variance of the white noise comes out to be 87.63 divided by 100. So, once you find out Ci, again remember the summation is for the whole set. This point I am repeating time and again, do not get confused by the n which we did for the case where short selling was not there, and in this case where n we have to find out for the whole set where short selling is there. So, there is conceptually two different concepts. So, once you find out the values, these are the values which you have for all the particular stock going what n at a time. So, the values is basically 4.52. Now, there is no C star which is maximum, because all of constant, as we are considering all the assets due to short selling as well as not short selling to be there. Hence, we only have one value which for our convenience we have denoted is as C star. For the time being, consider that is C star, which is the value which we just found out is 4.52. Assets with values of Ci greater than this value would be included in the positive sense, asset with less than C star would be included in the negative sense. So, there is no C star which is maximum, we are considering all the assets due to concept of SS, which is short selling. Hence, we only have one value which for our convenience we will denote by C star. Assets with values of Ri minus Rf divided by beta I greater than C star included in the positive sense, less than equal to C star would be included in the negative sense. Remember one thing, the summation has to be done for all the particular stocks which are there in the box, with N is the whole population of assets which you have in front of you to formulate the portfolio. Again you use the same formula, find out WIs which are the weights, and basically CI star or C star is given by the same formula, but with a slight change. So, change is this, N is always equal to 10. So, now with this let us do the calculations. If you do the calculations, what we have is WIs, which is the non-normalized weights, is given in the second column. So, first stock would have about 10%, while the last stock would basically have a percentage which is basically negative. So, what we are trying to find out is that whether the sum sums out to be 1. The answer is no. If you add up, they won't come out to be 1. So, what you do is that again normalize them, but remember that if you use the Lintner's definition, this should always be true, that the sum of the mod of the weight should always come out to be 1. In case if you do not use the mods, obviously you will get a different answer, but in that case practicality does not sound very good, in the sense that when you are doing short selling there should be some collateral, and if you read the paper of Lintner, it means basically when you are doing the mod, it basically means that whatever you do short selling, there should be compensatory collateral such that you are able to utilize that money in case if you default. Say for example, I am trying to basically go for a short selling and buy particular stock or loan a particular stock from a certain person. So, obviously, there should be a collateral, because in case if I default, that person can utilize that money in order to compensate the overall risk he or she faces. So, considering the concept of Lintner definition or non-Lintner definition, whatever it is, you can solve the problem. So, once you find out the normalized weights, see very interesting thing. One is for all the till the fifth one, if you remember, they are being done in a positive sense. That means all the stocks would basically be done because their values of excess return divided by betas are positive, and for the second set, that is from the 6th to the 10th, all the stocks would be done in a negative sense, because the values of Ri minus Rf, which is the excess returns which you have with respect to the beta, is negative. So, obviously, those would be done on a short selling sense, and try to basically divest or utilize the money in those stocks for which there are basically positive returns, excess positive returns. So, what actually it means that you would basically be utilizing about minus 1.45 in the total value sense, or percentage wise it will be 144, 45. The second one will be 425, third one will be 566. So, these are the percentage wise excess amount which you will be borrowing from these 6 to 10 stocks and trying to basically invest in the first 5 ones. So, obviously, it will mean that you will borrow some money from this 6 to the 10th and invest in such a way that the total amount of percentage investment in the first one would be about in the tune of 615%. The problem has the condition that SS being allowed using this Lintner's definition, riskless lending and borrowing for risk free interest rate can also be done. But remember, Lintner's definition need not hold true for any application where you will consider the sum of the weights is equal to 1, but not the mod concept. The rule works as follows: find the excess return to beta ratio for each stock under consideration and rank them from the highest to the lowest. The optimum one for investing in all the stocks is greater than C star, include, less than C star, include, short selling sense. So, now we are doing the Lintner one, again the same formulation, have 10 stocks, their returns, second column, the excess returns to the risk free interest rate, the third columns, the betas are given, the white noises, variances are given, and then you find out the excess return which is Ri minus Rf divided by beta, and basically rank them from the highest to the lowest. Again, do the same calculations, but remembering the fact which I am repeating time and again, this N is always 10. So, that means you are including all the stocks, whether in the short selling sense or not in the short selling sense, that will come out very easily as we continue doing the calculations. The value of so-called C star, there is no maximum value of C. So, so-called C star, let us mention it as C star for our convenience, comes out to be 4.52. So, again you will include, not include, depending on those values being greater or less. The CI's values are calculated using N is equal to 10, weights are found out using the same formula, and C star value as you have noted is 4.52. Once you do them, now you see a very interesting thing. These are the cases where you basically invest in a positive sense for these 5 number of stocks and negative sense in these 5 number of stocks. But when you do the normalization of the weights, considering the Lindner's definition, they come out to be quite practical in the sense, because in the other cases, in the last problem where we consider, they were percentage of about 600, 500, 400, which practically is not right. So, if you watch this problem and solve it using the Lindner's definition with respect to the non-Lindner's definition and usage of that formula in the just solved problem, this means that you will invest in a negative sense about 1.8 percentage of your total money in the 6th stock, while for the last one you will invest about minus 25.5% in the 10th stock. So, corresponding the amount of money which you will basically divest in the first 5 stocks would be given as in ratio sense it would be 0.07, 0.09, 0.09, 0.21 and 0.20. So, obviously, you can check double check that the sum of the mods of the weights comes out to be 1. Remember that when you are finding on the weights, for the Lindner's definition is sum of the mod of the weights for all the 10 stock. For the non-Lindner definition is sum of the non-mods, is you will not take the mods and find it out, that comes out to be 1.